Music theory with Microsoft Excel. Auto-transposable music system through all 12 collections of 7 notes, automatically rotatable through all 7 modal perspectives, changing the tonics as we do the rotation. Part number 6. So get ready and some coffee because you ain't never seen rockin' unless you excel at rockin', for which Microsoft Excel is required. In Excel, if you don't have access to this workbook, that's okay because we basically built this from a blank worksheet but started in a prior presentation. So if you want to build this entire worksheet from a blank sheet, you could begin back there or just build the part of the table that we're currently working on. If you do have access to this workbook, though, 4 tabs down below, including a very colorful fretboard tab we may refer to, an example tab, in essence the answer key, the practice tab having pre-formatted cells, so you could practice the practice problem with less Excel formatting. But if you don't have any of that, that's okay because we will continue to work in the blank tab where we started from scratch in a blank worksheet, and we'll be continuing to work in essence in the blank part of the worksheet, practicing not only our music skills but also our Excel formatting skills as well, for formatting's sake. Let's go on over to the example tab to get a quick reminder of our overall objective and what we have done thus far. The objective being to have a system to write down our musical ideas, our songs, our melodies in a way as efficiently as possible. Also automatically being able to transpose the information we write down into all 12 collections of notes, also automatically rotating them through all 7 modal perspectives, changing the tonic as we do so, noting that this is what I think the DAW systems in the future will have the capacity to do, because it's useful particularly for people that don't have a musical background, that haven't learned the piano, for example, being able to change things and rotate things easily by ear. So we started with basically a MIDI numbering system. This is kind of like the background information. And then from a music theory side of things, then we looked at the local distance numbers for our notes. We also have a numbering system for the 7-note collections, which is the perspective that we want to view things from, because that then will allow us to do our rotations, giving us the 2 dials to rotate, that being the 12 collections of notes, and then rotating through the perspective of each modal position. We then looked at the chords, remembering that a DAW system or sheet music, for example, even if you're writing it down by hand, would be more efficient if you were able to write basic chords rather than stacking the notes on top of each other. Note stacking working quite well if you have, for example, multiple different instruments in an orchestra playing a chord with multiple instruments. But if you're doing one instrument, like a guitar, for example, it would be good to have an option of at least the basic chords that are all constructed from the same 7-note collection, and we can write those chords as well from the perspective of like a Nashville number system, so that we remove the note name, defining it by relative position, allowing the chords to be transposable to all 12 collections of notes, as well as rotatable through all of the modal points. We then focused here on the actual nodes. We're going to touch more on this time, and that will become part of the problem when we convert from our data input system to like the MIDI system. This is going to be the perspective of the Nashville number notes on the left, 1 through 7, but adding all 12 notes from the perspective of a Nashville number system, 0.5s representing the 5 notes that are outside of the 12-note collection. So this gives us all 12 collections of notes. We could see it down here, same thing, but then this gives us the letters instead of the number of the notes. Then we have the data input. So when we do the data input, this is kind of like our sheet music. So even if you're not doing a computer system, if you're just jotting down your sheet music, I would recommend that basically you start writing your sheet music in a way that doesn't refer to note names, but relative position names, such as the Nashville numbers, for example, and chords built off of the nodes. Why? Because then you don't have to rewrite when you want to transpose. It's all transposed already. You just have to tell people what key you want to be playing in. And but you can also write it the traditional way. And if we were to be converting things, then we can easily convert back and forth between two systems using, say, even ChatGTP or some kind of AI system can do it automatically because it's all logic based. But if we're doing our DAW system in a database, then we should clearly be able to write it any format that we want. Traditional format with the actual letters, which can then be transformed, removing the letters from a relative position perspective, allowing us to then transpose it easily as well as rotate it through multiple modal positions. Remembering that this middle bit then is representing one octave. The middle octave would be like the one around C4, for example. However, I'm going to say that this will start on whatever the lowest note is and go 12 steps up from there. So if it's a C, it would be going from C to C, right? C4 up to, B4. But if it was a D, it would be going from D4 up through D5, right? And then what we're going to do now is try to take this and then expand it over into our MIDI system. So now we're going to look at the MIDI system. To do that, we have to take into consideration the octaves. So in other words, we converted this information here to this information, meaning this 24 now represents the MIDI number that takes into account the octaves. It's actually not 24. We'll talk about that later, but that's the general idea. It's a higher number. And we're going to use that then to be able to generate, expand from this perspective to this perspective. This is what I would expect a DAW to be able to do if it's more sophisticated. Allow us to write it in note stacking format and then transpose it over here so that we can compact it together, or write it in a compact format and allow us to then put it, the note stacking format break out this way. A sophisticated DAW system, which is what we should have these days, should have the ability to do this. I don't believe they currently do, right? So let's go back on over and just map out how, in essence, we could do this. I think a DAW would be a little bit more detailed than what I'm doing, but you could see the map out. And then if you were to create a DAW, which I hope someone does this way, then I think this will give you the general idea. So we have then here, what we're going to do is we're going to map out just this middle bit. Now I'm going to map out the middle bit here, which uses the notes that are based on the absolute numbering system. So we have our absolute numbering system over here. So this middle bit represents one octave, which for us is middle C, so the middle of the piano, which if I was to break out into like a DAW system, note stacking, it would be 12 notes, right? We'd have 12 notes going from C to B. We're going up. When we go up, that means we're going like to the right if it was a note number line on the piano, meaning going higher up in pitch. So then this is the numbering system from the relative perspective from the Nashville numbers, having 12 Nashville numbers instead of 7, adding the 0.5s for those 5 notes that are outside the collection. This is the local numbering system for the notes. So the notes can be numbered 1 through 12, which I put at A is 1, through G sharp is going to be 12. And then this numbering system is the MIDI numbering system, meaning this is the note numbering system that gives an absolute numbering system for MIDI. Not really useful for us for us to memorize this numbering system from a music playing standpoint, but just to map it onto what the MIDI has, this will take into account the octaves. So what we did is we did our data input up top, right? We've got our data input this way that we converted into the MIDI numbering system for like middle C. And so now we want to pull this over here. Now, to do that, these numbers are going to be fairly easy to do that with because I can just convert this to the number. But these chords become a problem. Why? Because these chords represent multiple notes. If we're talking about a 3-note Ionian, that would be like a C major chord. It's got 3 notes to it. So I need to be able to pick up the 3 notes related to this and then stack them in my MIDI system. Now I could do that because if I go over here and we look at our chord layout, here's all of our chords laid out by just the number, by node that we're in. And I then have the naming convention over here that's based on what key we're in. And we can actually list out the nodal points. So I can actually, these are the relative Nashville numbers, which can be laid out. So I can do that, not a problem. Great. However, we still end up with an issue because if I have a chord that's built off of a G, for example, traditional chords, we want them to be going up, meaning the G is going to be the lowest note. If we're going to have an inverted chord, then most likely you're going to have to stack it yourself, right? Meaning the G should be the lowest note. And if I just use the notes in this column, that will not be the case in that format. So it's going to get a little tricky then for us to try to convert this to chords, to the 3 notes, and be able to break out the 3 notes going up the way the notes would normally be stacked instead of having an inverted chord for these chords that are built in here. In other words, if this was a Locrian here in the key of C, the Locrian is going to be, or if we're going to have a Mixolydian, which would be the G, right? Then I'm going to have to say that G is going to be the lowest note for that chord, and so it's going to go outside of this range. So even though this is in this range, when I stack the chord, this chord is going to reach up into the range up here, a higher octave. Okay, so I'll show you what I mean. So let's see if we could just kind of work this out and say, okay, well, how is this going to work? If we think about it, this data input row represents this entire red column, but also out to the right in an equal distance as is the width of this orange rectangle. Why? Because this middle data input row has compacted the information down and represents a 12-note distance starting in this case on middle C or C4 and then going 12 notes up from there, also going past that red bit sometimes when we deal with the chords. So if we're just looking at these numbers, for example, these represent 1 note that's going to be in this 12-note distance. That's the first thing that we can basically map out and say, okay, that makes sense. So if that were the case, how could we basically map that out? We could say, all right, well, that would be an equals to an X lookup, and I want to find this 60. This 60 represents that C, and then comma, where do we want to find that? I'm just going to find that in this one cell. Now, it's not going to be there. It's a problem because that's representing a chord. But I'm going to keep that for now and then say, comma, I'm going to return that as well. So that's going to be our starting formula. And then we'll say enter, boom. And so there we have it. It doesn't work, but it should work once I get over here to that 60, right? So if I copy that across, notice even the ranges are going to copy across because I only have 1 cell on the range. So I do want to lock this cell, however. So I'm going to double click in here, that first one. I'm going to say F4 on the keyboard, lock that one down, and then I'll copy this to the right and say, does it work when I get out here to the 60? There, the 60 worked. That made sense. And then it stopped working out here again, and that kind of makes sense. Let me see how far out we can go for a second. Let's do this. I'm going to take this orange bit right here. I'm going to take that orange bit and then format paint it, and I'm going to put it right there so we can see how far out that goes, and we can match it. So if I take this out to here, we're going to say, okay, so that makes sense. And then above that, let's make this whole bit above it orange. Let's make it like let's make this whole thing the middle orange bit, or maybe a lighter orange. I don't know. Let's make it like this color. And then we'll say, let's put some borders around that. Now, when I copy it up, it's going to have some problems. So if I double click on it and I look at what's happening, when I go up, I want this 60 to actually move up. So right now I have it locked down. So that means I want to unlock the number side of it so it can move up on this column. So I'm going to say remove the $sign. That's called a mixed reference. Also, this is pulling from this middle row. When I copy it up, I don't want to move up this way. I want it to still be in this middle row. So the ones we're pulling from, also we don't want them moving up on the number side. So I'm going to put a $sign before the number side here, $sign before the number side here, and then okay, and then let's test it by copying it to the right again. It should give us the same thing going this way. Boom, the 60 is still good. Okay, and then I'm going to copy that up. I'll paste it formulas only so it doesn't overwrite the color. We have that formulas only, and then you can see the pattern here, right? So now I can see, okay, that makes sense. Boom, it's pulling this one, which is here, and that's a D, and that would be here, so that makes sense. Now, if that was it, that would be great, because then I could just go in here and maybe say, if this was an if NA, then I'll just embed that whole thing and say, then what are you going to do at the end of it? We want you to say comma, 2 quotes, meaning make it just a blank space, or put nothing there, and then close that and say boom. That would give us a blank space. I can copy that across, boom, and that would be great. And then I can copy that up, and it cleans it up a bit, right? Boom, and bam, great. So now that looks nice and clean, and it gives us kind of the DAW type of format as those are moving up. But it of course doesn't do anything for these chords. That's where it gets messy, is with these chords. So let's just try to think, let's put the chord like down here. Note what we started to do is break down a complex problem into simpler chunks, meaning the problem that we have over here is that we have both chords, and then we have these numbers that represent notes. And we first said, well, let me do the easy thing first and pretend that all we had were notes and figure out a formula that would work, which we have done. Now we have the more complex half of the problem, which I would like to think about separately, try to build it out in its own cell, and then figure out a way that we can put those two things together so that we can have one big formula that's going to do everything we need to do. Now, of course, the problem here is that these are representing chords. Here's the actual standard chord name down below. This is the relative position chord name, and we need it to be able to stack multiple notes on top of each other as we pull it over here. So somehow we want to be able to say, hey, look, each of these formulas that I have, I want you to look up something in this area, whether it be the note name, whether it be the number from the MIDI system, whether it be the local number or the relative position number, Nashville number system. I want you to be able to find that and then tell me if I should return that in my MIDI system, right? So in other words, if I was to find this 3-note Ionian, that would be a C major. So you would think that that would have a Nashville number 1, and then a 3, and then a 5. So how could I do that? Well, I could do an X lookup of this over here, and if I do an X lookup, then I can find the chord on this side. That's great. But then what would I return? What I could return is this columns. What is this column telling us? It's telling us that those are actually the Nashville numbers, the modal points. So the 135 is the 135. If I build something off of a Lydian, it's going to be a 461, meaning those are the Lydian, the Aeolian, and the Lydian, the Aeolian, and the Ionian, right? So I have the modal points, and that's something that could work. So let's go back on over and say, all right. So what I would like to do, I could stack this together, and then we're going to have. It's going to be more complex than that, however, because I'm also going to have to take into consideration the octave. But let's first just think about it this way and say, how can we make a formula? I can say something like, well, let's do an if logic formula. I'm going to delete what's in this cell because we already have that formula in the cell to the right so that we can work in the cell that would be easiest to work within as we build a more complex formula. The first thought we might have is to say equals X lookup, tab, and then to go over here and say, I want to look up that chord, comma, where do I want to look it up? I want to look it up in my list of chords over here, right there, Control Shift down, comma, and then return. Then I can't return all 7 columns. That's the problem. So I have to do this like one at a time. So I could return this one, but this is just giving me the modal point and not the note point. So if I do that, that will give us a 1. And it's like, okay, well, that's great, but I didn't match that 1 over here. So if I copy that up, it's not going to, what I wanted to say is like, if you see the 1 over here, then give me the 1. If not, leave it blank. And I would like you to also do that for each of the columns, not just one column. So how can I make that better? I could embed that in like an if. So I can do an if logic and say, well, if tab, that whole thing, if that whole thing is equal to this number, that number 1, then, comma, what do you want us to do? Then I want you to give me the result of this X lookup. I'm going to copy the X lookup, not including the equal to. Then I want you to do that. Boom. But if not, comma, then what do you want us to do? Just give us double quotes, don't do anything. So then we'll say enter, and it should close it up. So then if I go into that, it's like, okay, that's a little better. So if I double click on this, if I was to copy that up, then I want the ranges not to move. So I'm going to make them absolute F4, F4 here, F4 here, F4 here, F4 on the ranges, $ before the letter and the number. And then this bit represents this area, and I don't want it to move up. So I want a mixed reference $ before the 27. That's here, and a $ before the 27 there. And then enter. So if I copy this then, and I paste it up here, formulas, boom, then it seems like it's doing what we want because there shouldn't be anything up here, right? Because it's looking at that 4, and there isn't a 4, there's a 1. So it looks like that would be making sense. Although, so that's great. But what I wanted to do, the next thing I would say is, as I think about this, is say, well, I'd also like it to look in each of these columns and return a 3 if there's a 3 there, and a 5 if a 5's there, and a 6 if a 6 there's related to the chord that I'm on, right? So it's like, okay, well, how can I do that? Well, then I could stack if logics on top of each other. So this is where it gets ugly. So I could say, well, that's great for that. But then let's first trim this down a bit. I could, on this second bit, instead of doing this whole thing again, because I just said that equals the 1, I could say that equals this 1. So if this is true, if that, then give me the 1, right? Okay, hold on a sec. It got messed up. Let me delete that. That was wrong. And then undo, Control Z, go into there again. Again, this second bit, if this equals that, this second lookup, this whole thing right there, let me delete it this way. We're gonna go from here back to here. I want you to return just that 1 right there. Boom. And that should be fine. Okay. The problem, of course, is that I would like to do the same logic test for each of these numbers and say, hey, look, if you see that chord, then return each of these columns if it matches the column that we're on. That's going to be the next step. We can do that with an if-or logic test. So we're going to embed a bunch of ors in order to do that. So what would that look like? So I'm going to double click on this, and we said we want to find that in the range, and then if that equals the 1, return the 1. Now, no matter what, we're going to return the 1 if we find the thing to be true. But this time, we have multiple things. If any one of the things are true, then return the 1. To do that, we embed an OR logic. So the OR logic usually goes right in front here. So if, and then embed OR. So now we have an OR, and now we have the X lookup logic. If that is going to be equal to this, that's going to be the first condition. Notice here we're on the second condition of the OR logic if I go right after that comma. So then I'm going to say, all right, let's do this slowly. We're going to say X lookup tab. Same idea. We want to look up this again. Look up that again, comma. Now we could copy and paste it, do this more efficiently, but I'm going to try to do it longhand so we can see everything. Same, I have to repeat the column, Control Shift down, and then comma. And then I want to then look up in this column. If you find a 3, if you find that 3, and then I bring this over here, that's the return column. If that is, that's going to close up the X lookup. If that is equal to this number 1, then comma, do that. That's going to be logic test number 2. Now I'm on logic test number 3. So X lookup, tab, and then put my cursor over here, and we want to say once again, look up that, comma. Where do we want to look it up? In the same column. We want to look it up over here. Control Shift down, comma, return this column this time. Control Shift down, and then going back on over here, I'm going to close that up with a parentheses. If that is equal to, once again, that 1, then, comma, do the return. But I need the next logic test, or X lookup again. And we're going to say if that number, comma, is, if that number, find that here, Control Shift down, comma, but this time return this one. Now I have blank spaces which I should fill in, so I have to say Control Shift and make sure I get the same length here down to the bottom. Boom. Find that, and then close up the X lookup. So I'm going to go back on over and say, all right, we closed it up. Shoom. And so if that is equal to 1, okay, next one, comma. Once again, logic test number 5. We're going to say X lookup. X lookup, once again, is going to be, you want to find this thing right there, comma, in the column. We want you to find it in this column right there. Control Shift down, comma, but this time return this one in case it's a longer chord. Control Shift down, but I have to go through the spaces. And then close it up, and let's check it out. So we're going to go back on over here. If that is equal to that 1, okay, 2 more, comma. We're on logic test number 6, okay, so X lookup. And then we want to find this again. Little tedious, I know. Comma, where do you want to find it? We want to find it in the same dang range. Control Shift down, comma, but this time return this one in case it's a very long chord. Control Shift down until we get to the bottom. Close it up, brackets. Let's check it out. Let's make sure it's correct again. Boom. If that is equal to then this, then comma, logic, last one, logic test number 7, X lookup, tab, find this bit again, comma, put the cursor down. Where do you want to find it? Same dang place, same dang range. Control Shift down, comma. What do you want to return? This side this time. Control Shift down until we get down to the bottom of things. Close it up and then bring it back on over. And we'll say once again, if that is equal to that, then, comma, no more logic test. So I don't need another comma because that'll take me to 8. So I'm going to delete that comma and close it up, which terminates the OR bit. So now the OR bit is done, and I'm going to say comma, which is now on the if logic. If the value is true, then give me that 1, right? And then if the value is false, just like we had before, give me that false. So once again, it's just like the same logic test, but now we just made a bunch of ORs in there, stuffed them in, 7 different ORs to check out, in this case, the relative position, because we only have 7 Nashville number logic, and see if it picks those up. So we'll say enter, still gives us a 1. So it didn't give us an error. That's a good sign. Now, if I copy this up, then you would expect that it would be able to return this 3 and then this 5. So, but I'm going to need a bunch of absolute references. I should have done this as we built it, but I didn't. So we're going to need absolute references for all of the ranges. So I'm going to say F4, F4, F4 on all the ranges. Now you could do a lookup and do this automatically, which we'll do later, but I'll just do this manually for now. Just going to F4 all the ranges. F4, F4, and then F4, 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 and then F4, 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 F4. And then all of the VA27s need to have a $sign before the 27. So what I'm going to do is I'm going to copy this one, and these are all the blue ones. So I can see those. And again, I could do a find and replace, but I can see them all pretty clearly here. So I'm just going to paste this one with the proper $sign on the AV27. Boom. So we'll just go boom. And then this one with the BP36, again, I don't want it to move to the right. Wait a sec. Yeah, I don't want it to move to the right. So I need a $sign before, in this case, before the B and the P, right? Before this one. So I need a $sign here so it can move up and down, but not to the right. So I'm going to copy this and put that on all the green ones. All the BPs need a $sign. So I'll paste here. I'll grab this and paste, and then we'll put it here and paste, and then we'll put it here and paste, and then here and paste, and then here and paste, and then here and paste. Okay, so let's test it out. Let's copy it up here and say juju and paste. It didn't work. Okay, paso. That's a 1.5. So this one is 2. Now a good way to test it is if I double click on it, I can see the formula. I like using these things to trace. Boom. You can find that in the data tab, formulas tab. And then it's going to be over here in formula auditing. So I'm going back to the home, and I can see what the problem is. It's right there. See, it moved that one up there. So if I double click on this, what's kind of cool is I can say, okay, this one I can see shouldn't be up there. So instead of dealing with a formula, I could just grab it and say drag it down there. And this one's up there too. Drag it down here and say, okay, boom. So that one got moved up, and that one is an AV. It should be AV27 over here. So let's check it out. We have an AV27. So this one didn't have a $sign. There it is right there. So I'm going to grab this one with a $sign, and maybe I should have just done a find and replace. So I didn't. So there's an AV27, 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 and this one doesn't have a $sign. Copy, paste, boom. All right, so there's the 3. Bam, it worked. So I'm going to copy this and paste it all the way down again. Paste formulas, and so I still have the 1, and then now I have the 3, and now I have the 5. Okay, so that kind of makes sense. Now it's not giving me exactly what I want, because at the end of the day, I want this to give me the 60 over here, and I want to combine these two together so that it'll give me this or this, depending on whether we have a chord or a number. So what I can do then to do this is I can go over here and say, I like this concept, but what I'm going to do is I'm going to make more columns for these, and I'm going to say find that relative position over here, and then give me the related MIDI number. And so then instead of returning this, I can return, the MIDI number. Now I could do this right here, like I could say if any of those are true, return this MIDI number, maybe I should do that right now. I could say return, if any of that is true, return this number. That would be a better thing to do, right? And then I can say, I don't want this to move to the right, so I can say F4, or I can say $, whoop, not there, $, here, $, here, and then enter. And that'll give me the 60, so that's a little closer. And then boom, paste the formulas. So that works. That actually works pretty good. Yeah, that works great. Here's the problem though. So let me copy this all the way across this way. Or let me copy it out to here. Let's copy it out because those are where the formulas are. Paste formulas. All right. So that it works great. However, it's making inverted chords, meaning like if I look at this one that started on the Mixolydian, that would be a G that it starts on over here. So that would be like our G chord. So it started up here on the G with that Mixolydian, which I think is this one, right? But then instead of going up from there, it did an inverted chord. Why? Because it's looking at the Nashville numbers that are local distance. It's not taking into consideration the octave. So that's fine. That kind of works. But it doesn't. But I'd rather say, when I look at these chords, I'd rather say, hey, look, that Mixolydian chord is a standard, normally constructed chord, meaning the Mixolydian note is the lowest note, and then we go up from there. If you want to make inverted chords, then I would think that those would be the chords that you would have to stack notes on, meaning the chords that I'm going to put in there automatically are going to be normal chords where they're going to have only notes that are in the 7-note collection, and they're going to be stacked normally going upwards, adding 1 through 7 note chords. And then if you want to transpose them, maybe you can do an option to transpose them if you had a MIDI system or something like that. But I would say that then you would have to stack notes in order to get more complicated to transpose or to make chords with notes that are outside of the alphabet, or to remove chords from like a 7-note chord, kind of thing. So that means, so this is great, but I'd like the ones that are built up over here to expand up into this area. So how could I do that? Well, what I could do is I could say, one thing I can do is I could go over here, and this is what we'll do next time, is I'll take these numbers and I'll say find those numbers over here in the space that we're working in, and then give us the proper numbers in this space. So then I'll map out this. So then when we do our X lookup, I'm just going to pull over the X lookup that we pulled over to these numbers to the new table that we built over here, and then that'll be a way that we can take into consideration the octaves, so that the chords will build up properly, so that the tonic will be the lowest note and we won't have inverted chords. And then we'll combine these two things together, right? Then I'm going to think, okay, once I can figure that, then I'm going to say, how can I put this together with these over here, these two formulas together, so I can say, look, if it is a formula, do what I need to do to build a chord that stacks on top of each other. And if it's just a note, then just give me the note. All right, so that's what we'll do. We'll keep on working on that next time.